Hey, what's up? Welcome to another episode of the Buoy Report. This is a fun one. This is one of my gurus in surf forecasting. I sat down with Mark Sponsler via Zoom and just talked story over what it takes to be a forecaster and the science of forecasting and waves, and just really nerded out on surf forecasting and energy of the ocean and some little woo stuff. But hope you enjoy. This is a fun one. Aloha. Boom. Hey, what's up, everybody? Welcome to the Buoy Report Podcast, where we are documenting waves of energy, from big waves to renewable energy waves, thought waves, and mind waves. Hope you enjoy. Aloha. Carry on. All right, we are live. So, hey, how's it going?
It is going great. Good, great to be here. Good to see you.
Yeah, finally, good to see the face that I see every Sunday evening. So, little intro. So, this is Mr. Mark Sponsler. For those in the know on the big wave scene, there's a much circulated text of the inner circles when a big swell event, and we're always like, what sponsors say on the event? So. Usually Billy or JoJo or somebody, or Jamie Mitchell or somebody's got it, and there's a couple screenshots that go around. But you're the man. Thank you for making the time to sit down with me, sir.
Well, thank you so much for having me. I really appreciate it.
Yeah. So let's just do the quick little intro. Let's start with the who, what, why, how, where. Today is Thursday, the day after Thanksgiving, or Halloween, or 2 days after Halloween.
Thursday, the 2nd of November.
Yeah. So I'm calling from Hawaii. You are
in California, just outside the San Francisco Bay Area.
All right.
A hop, skip, and a jump away from Mavericks.
All right. And just give us the little professional intro, so we know who you are. So
yeah, I am Mark Sponsler. I am the owner, forecaster, technology guy behind Stormsurf.com, a website dedicated to surfing, but weather and snowboarding and education of people, so they have a better understanding of how the environment works, and that they live in an environment that is not man-made, not man-controlled, but that has a lot of influence on everyone's daily life, and that you need to respect it if you want to live in it.
Yeah. So if anybody is familiar with surf forecasting and is keen or in the know, I guess there's two of those, is your website, stormsurf.com, is probably one of the best free sites out there. The wave models, starting with the wave models, and then those surf models for the local forecast. I swear, we click at the local spots, especially for Hawaii, especially for Maui, when that surf number, you've been dead on over the years. Like it's Hawaiian scale. If we see a 20, it's going to be a real 20-foot Hawaiian swell. So your scales are right. You're not part of the hype crowd of some swells, I think.
Yeah, no, I really try to, if anything, underhype it, because there's nothing worse than going to your favorite surf spot and thinking it's going to be giant, and you look at it and you go, "Where's the swell?"
Nice. So I guess let's start at the origin story of the how. Is it you were trying to outsmart everybody, and you found the data set first and foremost, or how'd you get into the storm?
It goes even way back further than that. I moved out here right after Mark Fu passed away, probably a couple of months after. I wanted to surf Mavericks, met Jeff Clark. Jeff was great. He took me out a couple of times, sort of showed me the ropes. Or fixed up a board for me, or got me a board. And then I started, I was big into surf forecasting anyway, but I didn't really have anything organized. I just did it for me and my friends. So over time, it sort of evolved into this. Oh, I'll send an email around to Jeff and maybe a couple other people. And then it's sort of God, it's a pain just putting it out and sending emails to everybody. So I built a little website. This is like in 1995 maybe. So we were still on dial-up modems.
Yep.
And so it was like, okay, I'll build a single page and put it on the internet. And I was shocked that within like 2 weeks, there was like thousands of people had viewed it. I'm like, what the heck? So it just sort of grew from there, and it was just a text forecast. But then a little bit at a time, it was like, God, I got to figure out the model thing. I got to figure out how to do that. Fortunately, I had lots of buddies in the IT business, and they gave me some nudges, but I had to kind of figure it all out myself. But what I wanted was models that had the labels on them where, like a lot of the wave models just show 20 to 30 feet and 30 to 35 feet in the height of the significant, the highest seas inside a storm. And I wanted to nail it down to I want to know exactly how high the seas are, because the higher the seas are, the longer the period and the more energy that'll eventually reach your beach. So I started building models that fit what I wanted to look for as a surfer and not as a boater or whatever NOAA was dishing up. Nothing against NOAA, but I wanted what I wanted, not what everyone else wanted.
And pinpointing the geolocation of where each spot was, and just taking in the little local bathymetries and the like, what would you call it? The blockages and all those kind of
right. The swell shadows and all that kind of stuff. Exactly.
Okay. And how has that model evolved from that first data set? I mean, obviously the data's probably changed, and then the models have changed and grown over the years.
Yeah, so NOAA, it's really NOAA's model, the WaveWatch 3 model, or they call it the GFS wave model now.
Okay.
It's really a function of what they are doing on their end. They keep improving their software. I mean, the simple thing is the cost of computer memory has dropped dramatically since 1995. Yep. And so the price of CPUs and processors has dropped dramatically. So they can throw a lot more horsepower at this our little community, which is the ocean community. And the models have gotten way more accurate just because of economies, in the computer hardware world. And then, of course, there's always people, they're always tweaking the model and trying to make it better and more accurate. It's never perfect, but it's a good approximation.
Come a long way. So I could think back when I was thinking about surf forecasting. So I remember it was in Hawaii when I was a little kid. And this was for my dad, guys. You never missed a 6 o'clock news. 6:22, the weather guy would go on, and you'd split between and kind of see who would have the best. There'd always sometimes be a satellite map if we're lucky.
Yep.
And you just that was it. And that was when we were kids. And I remember, so my mom was a flight attendant for United and Pan Am back in the day when I was kids. And we'd take her to the airport. My dad would take her to the airport and drop her off from the Maui airport. And this is before TSA and security. And you could park, and they had the National Weather Service and the tower. I guess the airport tower. There was this office right there at the curb. My dad was friends with those guys, and he would always poke his head in like once a week in the wintertime, just like, "Hey, what's going on? You guys see any weather maps?" Or and he would see the original I think it was satellite images when you'd see the isobars and the things, and every now and then you're like, I distinctly remember, you got to see this one. This is a cool one. Come check out this one, or he'd be tagging along and. His friend would give him the report. So that was like a true origin back in the day. And then probably evolving from that was, I think Pat Caldwell was one of the very first that was really on it. And he used to do his once a week ones in Hawaii, and we all lived and died by those ones. And he was really on it. And then when I started boat driving in Tavarua, there's the coconut wireless ones. It was still, the dial-up was so bad you couldn't get a model. We were still getting the wave faxes from Shaun Collins style. But we had a friend down in Raglan that would call us every single time and say, "Hey, Raglan's 10 feet. It's huge down here. Get ready. You guys are going to get a swell in a day and a half."
Wow. It's amazing how far we've come from calling from someone down, down under to get there's surf. I don't really know how, now I want to know exactly how high the sea heights are in the middle of the storm. I want a satellite pass going right over top of it that confirms it. Then I can go and calculate the exact great circle path, what the angle's going to be, the decay rate, blah, blah, blah. And it should be arriving here, you can nail it within a couple of hours and maybe 6 inches of height.
Yeah, the other coconut wireless was in the summertime. That was even harder to forecast. My uncle and dad guys had friends in Tahiti. They'd call them up and, yeah, he's huge. Get ready. You're going to have 3 days. You're going to get a south swell.
Human buoys, right? That's what they were. I mean, there's still not a good buoy off of Tahiti. I'd love to have one. There used to be the Christmas Island buoy, which is on the equator, south of Hawaii, but that's been down for years now.
And then there's, before the internet, then there was buoys, and you'd have to call the National Weather Service or the weather radio, and you'd have to listen to the 10-minute spiel. Then at the end, they'd give you a buoy report.
Right.
So that's actually a question I want to have for you. So yours is your buoy page, your high res buoy page is one of my favorites now. That it's a snapshot, especially the Hawaii one.
Right.
And when you call like the National Weather Service, it's that significant wave height one. Is that an average of all the things that are churning through the ocean?
Yeah, that's basically what significant wave height is. And even what NOAA reports as swell is still like, basically it's the sum of all swells in the water above 6 seconds or something like that. That's one of the things that drove me nuts, because I want to know. So way back in the day, there used to be another website out of Florida, of all places, that had buoy data, and they would decode the swell and tell you the primary, secondary, and tertiary swells. It's like, I want that data. They went off the air, decades ago. So it was like, how did they make that happen? So I talked to people, and people that I know that respect and that work in the industry, and they gave me little tidbits and, well, try doing this, try doing that. And eventually I figured it out, but it took a long, I mean, that's probably one of the hardest things to do in surf forecasting, is take a buoy, decode it into its primary swells and primary directions.
That is so interesting. So that's kind of the essence of what this podcast is the expression of energy and documenting waves of energy. And one of the aha moments that I had of conversions of energy was, I'm an electrician by trade and sell solar panels, and we have a tool called an E-gauge, and there's other charge controllers. But when you're monitoring electricity, you get this data set, and it gets plotted graphically. It looks just like a buoy reading. And it was like that's, and then it was just like, oh yeah, we're measuring AC waves, not the direct current, but an AC current, which is alternating current, which is essentially waves of energy.
It's wave height and a wave period, right?
Yeah, exactly.
And that gets into everything is some sort of a wave.
Yeah.
But for the surf perspective, the waves and mapping the energy, the height and the frequency, which is, for people that don't know, is the period, the amount of time in seconds between successive crests of a wave, that is key to 5-6 second period wave energy is really like wind chop, just like wind blowing on the ocean surface. Whereas the sort of stuff that big wave riders are interested in is more like 17 seconds between successive wave peaks, which is much more, it's a measure of energy contained in the wave. And it's not even necessarily related to height of the wave, just the amount of energy in the wave. And of course, the longer the period, the more the energy. So a 2 foot at 20-second wave is a lot bigger than a 2 feet at 6 second period wave.
Yeah. And it's like that speed. When you say that second, it's the speed, the girth of that swell, the energy, it's almost like the force and mass behind it. There's a couple of variables all wrapped into one, right?
Yes, exactly. I mean, we feel it, surfers and people in the ocean feel it as there's a lot of power in the ocean today.
Yes.
And it doesn't even have to be big waves, but it can be when it comes, the ocean surges up the beach, and you can really feel it. It makes it very dangerous for casual beachgoers. Yeah,
it's so interesting how each swell that when we go surfing or when you're in the ocean, what a different signature each swell is, or what that perfect magic number is for certain surf spots and stuff. Like a perfect pipeline swell is 10 at 17. Not too long of a period, not too short of a period for that second reef. You want it just capping, it's just sneaking through the third, where the long period starts focusing, and then it gets focused into that second reef zone. Or like Jaws, like those rising long period is just frightening, because the waves are moving so fast. They're doing these double ups, and they're just stacking out on the horizon, 10 wave sets.
Yep. I know. I mean, we just had a recent swell from an extratropical storm. You guys had it. We had it over here.
Yep.
The opening swell of the hopefully the epic 23-24 El Nino's big wave surf season.
Yep.
But the opening swell was extremely powerful. We had 22 to 25 second periods over here, and you guys were pretty much in the same place.
Yeah. Exactly.
And the opening swell for the Super El Nino of 97 was the exact same setup.
Really?
It was an extratropical storm that hit the dateline, got supercharged by the jet stream, had 50-foot plus seas, and did the exact, gave like 3 days of surf, at least over here, and all with these like 20 plus second period swell. And this year did the exact same thing, only 2.5 weeks later than the one in 97.
All right, we're gonna put a pin in that because I really want to get to the El Nino side of things. But let's start with let's come back to the storm development and energy and how it. And if anybody has watched your video, I urge you to just go take a peek of it, especially during peak swell events or peak winter events. And there's some that I've bookmarked, some of the hallmark ones, just to kind of go back as earmarks. How do you know when we're about to get a good morning? Can you just tell by the jet stream already? Like, people always say, how do you know with swells? I'm like, well, there's a 16-day forecast. At 16 days, we probably got about a 20% confidence. 10 days, it starts ratcheting up. 7, we're getting into that 50, 60%. Maybe 3 days out, swells on the water. Now we're 70, 80%. I think I'm pretty confident. And the last 24-hour period is local winds. And let's figure out we got to say a prayer for local winds to hold together.
Always.
Yes.
Yeah. So the models are notably unreliable. I'll say even more than a week out.
Yeah.
So like you said, 20% chance. I'd even give it more like 5%. But when you get in that week window, and this is just the storm, this is not the resulting swell. You get a week out, you go, hey, it looks like there's going to be a solid storm. And the first thing I'm really looking at to give me a tell is the jet stream. Okay. And the jet stream is winds that are up about 30,000 feet. They kind of flow in like a river around the planet. Yep. In the northern hemisphere, they typically flow on a good year, like an El Nino year. The jet stream dips further south over the Pacific. It tends to have more energy in it. That is tropical energy. That is warm, moist air from the far west Pacific gets lifted high up into the atmosphere. It gets caught by the jet stream, and that warm, moist air has a lot of kinetic energy in it. It starts traversing the Pacific and then starts waving in troughs and peaks, if you will, or troughs and ridges. And those troughs, those downward dips in the jet, help create a counterclockwise circulation aloft that also manifests itself down at the ocean's surface. And that ends up being a low pressure system. And those are typically associated with a lot of winds. They're storms, basically. Yeah. And that's how you make waves. It's a transference of energy from the air into the ocean. So you're taking wind energy, that wind blows on the ocean's surface and literally transfers the energy from the wind into the ocean. And it sort of takes a different form in the form of a swell. And as the swell radiates away from the fetch, it grooms itself out. You think of like the perfect storm. In a storm, it's all just bouncing and all over the place, and it's chaos, right?
Yep.
But as those swells move away from the fetch, from the wind, the weaker, lesser period energy dies off, and what you're left with is these basic sine waves moving across the ocean surface, moving toward whichever direction the wind was blowing. It moves in that direction, which turns into the period charts, the energy charts that you and I see on the buoys when they get close to our coast.
So there's been a new metric that I've been seeing popping up on a couple different forecasting sites, the Joule.
Everyone's talking about that now.
Tell me about it, because I've heard some interesting theories. Like,
everywhere I go, tell me about joules. Tell me about joules. And I've gone, I mean, it's a measure of energy, but what you can do with that, it's just another way of looking at the period in seconds. Okay. But what we do on Stormsurf is I take the joule energy and convert it into height. so you can see the actual height of the swell. When you look at NOAA's website where they have the joules, it's just a spike, but it's not really associated with any height. You go, that's a big spike or a small spike, but the scale changes depending on how much energy is there. Whereas what I'm trying to do is just give you a fixed scale, and you can just look and see how much energy is at 20 seconds or 17 seconds, the whole way across the spectrum from 0 seconds up to pretty much as high as you can go as 33 or 35 seconds, and then assign a height value to it. So it's a swell of 20 seconds at 2 feet or a swell at 20 seconds at 10 or 15 feet.
Gotcha. That's like, it took me, what you just explained took me back to like high school chemistry when they were trying to explain what a calorie is and you burn an almond and how much it raises the water temperature. There was like the original calculation of that.
Exactly. And that's what it is. There's a bunch of math behind it. It's not super complex, but you can convert those joules, if you will, into feet.
So that data has always been there, though. Like it's nothing new. That's kind of like now they're just.
NOAA's been reporting those energy graphs. I've found them on their website. I mean, from decades ago.
Okay.
Now it's just trendy to talk about it because for whatever reason. Well, I mean, it's good because people are now more dialed in. They're smarter. They're learning. That's the whole point, right?
Well, the guys in the know, and there was a certain person we call Senator Greg Long. He taught me this long time ago. I have an online Google Drive of screenshots of all my best swells that I've saved over the years of my favorite swells, and basically it's cloud break, jaws, and pipeline are my big three that my historical good ones. And basically it's the long range forecast, what the map's looking like, usually 24-hour a hindcast shot, and then the buoy reports that go along with that. And basically, and you correlate, and I've gotten it down now, especially like we're always, the Fiji ones are like a very elusive unicorn swell. And so they usually run hot, but half the time or 80% of the time, they always fall apart. And if that map doesn't look, it's not falling into that, what would you call that? Like putting in a tracing paper over it. And you're just like, nope, it's not the same. And you just like do a comparison. So do you have the secret hard drive of those historical records of some of your favorite ones, or you just?
I do, but I mean, so much of it now is I've been doing this for so long. I can literally just look at a chart, look at a storm, and go, "That's in the Goldilocks zone," or "It's not." Pretty much,
Gotcha.
Just like what you're saying about Fiji. Fiji is you got to be there, and it's the storm. It's not a That's the other thing is the difference between a forecast and what's actually happening. A lot of people get, a week out, oh, there's a giant storm, there's going to be a swell. And I go, what are you talking about? There's no wind actually blowing on the ocean's surface yet.
Or half the time down there, the storm will be big and the fetch is just aimed the wrong way.
That's the other thing, right?
And then, like that fetch has got to be aimed there, and it's got to be long, and then there's got to be a nice little runway to catch it all the way through. Can't be a tropical storm that it's got to burn through. It's going to lose steam. All that stuff. Or that last message I sent you was you were telling me it was an error on the model, but it was like a piece of I thought like the ice sheet was sticking out.
Yeah, I know. I've gotten a bunch of
hanging into the fetch line.
I don't know what's going on with the model, but it's like they're having problems. There's a component of the model that they use to chart ice and the ice, where the ice is. And if that's off, it like thousands of square miles of fetch just disappear basically over land because you can't make a swell over a mile thick ice.
Yeah, exactly. I wanted to share one with you. This is the other little idea I had observation, I guess. I want to say this was almost the last El Nino run in 2016, maybe?
15.
15, 16.
Winter of 15 and 16, yeah.
Yeah, and there is a polar vortex became a mainstream media like buzzword that was in the news and everything. It was like the big cold bubble would come down, and I just saw the pattern. It was crazy because the pattern would come down. The polar vortex, you get this massive cold air would shoot down. It would run into like something tropical coming off of, say like the Caribbean zone, that hot air down there. Right. And it generally would turn into an East Coast low. Yeah. Travel across, and then they were turning into a Nazare swell,
Yeah.
And you can almost watch that mass of energy still travel across Europe, Asia, and it was coming across and turning into a storm into the Pacific, coming off in Asia. And that was actually one other big forecasting trick we used to have back in the day was it's snowing in Tokyo. And that would mean that would mean there'd be a good west swell. There's a big storm. If it's snowing all the way down to Tokyo, that's a big storm doing something.
Certainly.
The westerly winds
polar vortex field. Of course, so what's that? That's the day after tomorrow, that movie.
Yeah. But it became in the news and I was like, oh, we're gonna get a jaw swell in 2 weeks. And it would take that long for that little chunk of energy and just affect it's just water, right? It's a ripple. And now that energy's getting pushed around.
Exactly. But it's the same sort of thing we were talking about earlier about the jet stream. And, it starts somewhere. And typically it starts exactly by that, a mass of cold air building or a bulge of it pushing south. But that displaces warm, moist air to the north. And right along the front of that border, you get vorticity. You get the warm, moist air swirling around over the cold, sinking air. And that creates a storm. And you're in business after that.
Wow. Okay. Very cool. So it wasn't off. That was before.
No, you totally nailed it.
Yeah. Okay. So the other big important one that's on the top of everybody's tongues this winter, El Nino.
Yes.
And we've been tracking it. If you've been watching your Sunday shows, you've been watching that. I pretty much watch the beginning and I go right to the end of like the third to last bookmark where you have like I forget what you call it. But it has all the tails going up. It's basically a graphical, and basically it's a little.
Oh yeah. It's the sea surface temperature anomaly forecast for the Nino 3.4 region.
Yes, that one.
Yeah, exactly.
I'm like, where are we at now? I always just come back to that one. I just skip to that one.
Yeah, because that's a good place to do it, right? So where do you want to go? Because I could talk for an hour about El Nino.
Question one. We're having one. Yes.
Yes, we are definitely. So that is a good question. Are we in El Nino or is it still a forecast for El Nino? And I would say, so the trick here is there's two components to El Nino, the ocean and the atmosphere. The ocean has been looking like El Nino since June or even earlier. Okay, piles of warm water, which is normally sequestered over in the far west Pacific, is all piled up now off of Ecuador. And every day that warm water signal is getting warmer and it is expanding back to the west on the equator into the official El Nino monitoring zone. But the short is there's a lot of warm water that's normally, like last year and the year before, it was La Nina. And all that it simply is cold water off of Ecuador, which is really normal, in Peru. Colder than normal water. Now we're in a warmer than normal water regime. The atmosphere has completely flipped. And so typically what happens is when you have warm water off of Ecuador, it creates a lot of evaporation. The jet stream picks that up and it changes the jet stream pattern. Right. And it makes it dig in deeper over the Pacific, which then fuels storms over the Pacific and then brings us our surf and our snow and all that. During La Nina years, it's the opposite. High pressure dominates. It's cold water off of Ecuador and the storm machine kind of shuts down. And we kind of know that like last winter was the worst winter ever. And this summer was the worst summer ever, pretty much in memory.
But here's to put one little, I feel like those off seasons, the La Ninas, there's always a crazy outlier though.
There always is. So
it almost goes bang. There's one, it builds up to one big snap instead of a steady pushes. And like, that's the peak of winter and all that energy got released. And that's it. Instead of just a really steady, continuous of big.
And that's very well said. I mean, that's what it is. You get nothing, but energy is always building up in the atmosphere and it has to be released somehow. And then you'll get a push of the MJO, and I'm not going to go down that rabbit hole, but that sort of fuels the jet stream. And then the storm machine kicks in and you go for a couple of weeks and you have a whole flurry of storms. And then boom, that's it. It's over. It's blown its top. And that's the end of it for winter. Or maybe you'll get lucky and get 2 or 3 of those in a La Nina winter. Whereas in an El Nino winter, the big winter of 97, I recall there was I think it was 7 to 8 weeks of continuous 20-foot swells a week for 8 weeks over here in Northern California. And I'm sure it was much the same over your way.
Basically, you just get those three lows stacking up. One's coming off, one's flexing, and then one's running into the West Coast.
Right. It just turns into a machine. It just keeps going and going and going.
And then that translates into the water cycle, obviously going towards the mountains and all the precipitation. And
right. Everything that we need in California, because we're living day to day on borrowed time.
So what precipitates El Nino happening or not? And why is it just energy? That's the cycle of energy over years that takes to build up, and then that's where it gets expressed? Or is it?
In essence, that's what it is. It's a buildup of energy. So let's say you have your big El Nino, and then basically all the latent heat energy in the ocean and in the atmosphere kind of gets blown off. El Nino. So let's talk about heat management on the planet. All right. You have winter and summer. Okay. And you have cold and warm. But like in the tropics, you have thunderstorms, let's say. And I'm thinking of Florida when I think of that. And thunderstorms are a way to take warm, moist air way down at the ocean surface, lift it aloft, way up high to 30,000 feet. It hits cold air, precipitates out. But what it's effectively doing is acting like a chimney to evacuate heat out of the lower levels of the atmosphere. Hurricanes are like a mega thunderstorm without all the lightning, but it's the same thing. The eye of a hurricane is effectively a chimney to evacuate heat from low in the atmosphere to high in the atmosphere. Then you get into winter storms, which are the exact same thing, expressed a little bit differently, but they're a way to evacuate heat off the ocean surface. But then there's two longer term cycles, El Nino, La Nina, which are other ways of evacuating out heat, right? And then there's this thing called the Pacific Decadal Oscillation. So El Nino runs about every 7 or 8 years. Then there's the Pacific Decadal Oscillation, which runs in 25 to 30-year cycles that burns off heat in the ocean. We have the 97, 98 El Nino. The Pacific Decadal Oscillation went from a period of being basically like a long-running El Nino. It shut down, and we've been in the cold phase of the Pacific Decadal Oscillation since 97. So it's been 26 years now. We're thinking maybe, just maybe, that we're going to come close to the end of that cycle. When that happens, then the conditions for El Nino become more frequent, and you get into this sort of this background state where it almost feels like a continuous El Nino in winter months.
Interesting.
All of it's about heat management, though, and energy management, right? The Earth tries to regulate its temperature.
What is it? Would that be like chaos theory, or just down regulation, just basically kind of coming to a homeostasis? It's always trying.
Well, So what the planet wants is homeostasis, right? It's trying to get to a happy medium, but because everything's moving all the time, it's never just going to sit there flatlined, and you really wouldn't want it, because if it doesn't change, then you probably don't have change in seasons. You're not going to get rainstorms. You're not going to get hurricanes. You're not going to get surf. You're not going to get snow. Everything will just sort of sit there. So you get these extremes, but all they are is expressions of the planet trying to manage its heat, the heat that's contained in the lower atmosphere.
Interesting. That was a really good expression of how, like, I was in Costa Rica last summer. It's so freaking hot. And it would just be the most beautiful morning straight offshore. And pretty much 3 o'clock, there'd be the most torrential downpour. Skies would go dark. It'd come over from the jungle, all the water. And it was just like, you could see that hydro cycle just going in full speed with the heat.
Yeah.
But what you were saying, that homeostasis, like, my mind went, so essentially Earth is rotating or corkscrewing, if you ever see those 3D models, around this nuclear fusion reactor called the sun. And we're corkscrewing around it, but it's not a continuous constant path. There's little deviations. It's gravity and it's spinning, and the Earth. So those are the other little variables.
And the orbit isn't a perfect circle. It's elliptical.
It's actually a corkscrew,
and it's on its axis,
like that.
Right?
Yeah. And so those are the big deviations. So it's kind of leading into my next question is it comes back to climate change. And I'm really interested in what your opinion is of where we're at. I know humans are changing the environment in different ways. We cut down trees. We definitely poison waters. It's a very hot topic within mass media and all those kind of things. But is climate change something that's very real that we're doing, that we're accelerating, or are we humans just so short-sighted with the smallest memory and just cannot comprehend the scale of time that the Earth is? And these are just natural cycles, as we've said. You mentioned a 25-year one and a 50-year one with these data sets. And electricity has only been around 100 years to capture some of these things.
Sure. And so a lot of the discussion goes, well, the temperature of the Earth has always changed over time. There's ice ages and there's not ice ages. And I go, absolutely, that is true.
Yeah.
But what there is a clear correlation between the amount of CO2 in the atmosphere and the temperature of the Earth. And that all boils down. And it's not just CO2, it's methane, a whole bunch of other gases as well. And in essence, what they do is they trap sunlight in the surface of the Earth, raising the temperature of the Earth. And the regulatory things that we've all been talking about, the way the Earth manages its heat, it's those tools or valves that the Earth uses to regulate its heats are going to get turned more as the planet warms, and then there's going to be effects from it. What the effects are, we think we know, but I'll be honest, not everybody fully understands how this is going to go down. They just know that it's happening. Yeah. And you can look at the glaciers all retreating. It's pretty simple to see that.
Yeah. Yeah. Well, I talked to one of the quantum physicists, and he kind of done the math. And he's like, you know what? We got to stop burning shit. Just like, that's really the long and the short is stop burning shit. That's like,
so then I'll play that, because I've heard arguments on both sides, and I like to listen to everyone's argument.
Yeah.
And one of the arguments is, well, just get rid of us burning all the fossil fuels. But the hard reality is, and I don't even want to admit this, if you got rid of all the fossil fuels and weren't burning it anymore, as of right now, there's not enough solar, geothermal, and everything else to power our economy, and the economy would collapse. And not
100%.
only that, you wouldn't have electricity in your house anymore. So it's a real catch-22. I mean, I'm all, yes, let's go green, but the reality is it's going to not happen overnight. It's going to take time and a lot more emphasis on technology to try to get us there.
Yeah. That's right in my wheelhouse. So here in Hawaii, I'm Maui, we're a diesel generated island. I sell solar panels and batteries for a living. And we're just a drop in the bucket of how much the demand of how much energy is really being used and how much is produced. It's spooky sometimes, but it's doable. I think we're grabbing chunks.
We are. We have to, right? We don't really have a choice. We got to go this way, and I think most reasonable people understand it is the right way to go. It's just time. It's going to take time. I mean, it took time to get us to the point where we are burning, fossil fuels, because that's all we're people. That's all we had. And then when we find something that works for us, we just keep banging away. And now it's obvious. Solar panels, electric cars, maybe hydrogen cars, other sorts of ways to generate power are available to us that weren't even 30 years ago. I mean, 30 years is kind of a drop in a bucket for how this game gets played, but we're getting closer and closer, and little bit at a time, the reliance on fossil fuels is waning, and the reliance on sustainable, naturally available energy sources is taking over.
Yeah. The one I always come back to, what's the cost of doing nothing?
Yeah.
You can't just not do nothing. We got to keep taking little steps. Even if it's not perfect, it's a step in the right direction.
Right. We're not going to get to perfection overnight. It's going to take time, but people eventually will come around to, you got to do the right thing. And honestly, it makes good economic sense to do the right thing.
Yeah.
It's cheaper in the long run. I mean, how much money do you want to be spending pumping money into gas and giving it to the power companies when you can put solar panels on your roof and basically you have one outlay and then you're good?
Yeah. here in the islands, if you ain't got solar panels on your car, you shouldn't get an EV. You just got to eat. You just basically got a diesel car at the end of the day.
Yeah.
So, I want to circle back real quick on the climate change and like extreme weather events. And there was something that just happened in the news. Did you see the hurricane that went off in Acapulco?
Yes.
That happened really quickly. Like, I mean, the story with through mainstream, and this is again, it was unforecasted and it happened really quick in the scale of time. And it was people unprepared. It was basically a tropical local storm that flared up super hot, super quick. Some burst of basically some hot air or energy came out and just flared up, and it just went right into the coast.
Yeah, right as a Cat 5 hurricane.
Yeah.
And the reality is I tend to watch, I have family back in the East Coast in Florida, and I've been watching the storms there for decades, and we're seeing a lot more of that occurrence happening too. And it's not just, there's more satellites now. The satellites are way better. There's more ways to track this stuff. So yes, the total number of storms, some of it might be influenced by that, but the rapid acceleration of storms, it never used to be going from 0 to hero in a day or two like that Mexican storm. And the same deal's happening, maybe not that quickly over on the East Coast, but we're heading that way.
Yeah. Did you follow on storms? Obviously the Maui storm, yes. The Maui hurricane that made all the fires. It was such a, not to use a cliche term, but a perfect storm of the direction. It had already been a dry summer. It passed south of us, and it was such a hot, and then the fetch is what actually did the damage. I think the hurricane was like 100, maybe 200 miles south of the island.
Yeah, it wasn't so much. A lot of people were saying, oh, it's the hurricane. Not really. What it was La Nina fueled high pressure locked over the North Pacific.
Yeah.
And so that sets up high pressure north of the islands. That makes the trades in generally stronger than normal. And you're over there, you would know more than I. But trade winds, especially when they get moving, especially when they get funneled through canyons, just like it happens over here. And if you're dry because you've had, less rainfall than normal for a year or 2 or 3 years, then that with a spark, with a little bit of a hurricane south to feed the gradient, the difference between high and low pressure can, really fuel bad things.
Yeah. I mean, there was 90 to 100 mile an hour winds coming out of the valleys. It just compressed out of the valley. It was insane. And this is going to be a funny one. It kind of leads it. I had to lose some friends over this one and seriously block some idiots on social media because of my position and my industry that I'm in, that they were just the conspiracy, the chemtrails, and they're making the high pressure of over the coast and HARP and Pearl Harbor's there, and it's geoengineering, and it's part of the smart city. The first part is the smart city is the biggest horseshit ever because it's the hardest thing ever to get a solar permit, electrical permit here in the islands. So I really doubt that there's an agenda to make this accelerated smart city. But the lasers and the fire, how can wind get that strong? And I'm like, it gets 40 to 50 knots all the time in the summertime. And then there's just a couple degrees up, and now it's pressuring through the valley. How does it get that fast? Well, you ever heard of pressure like coming through the valleys? And the mountains make their own weather. It was a
Venturi effect. When you take wind and you funnel it into a smaller and smaller space, it just blows harder and harder and faster.
Yeah. Can you just put a comment on all the conspiracies of chemtrails and high pressure, and they're trying to drought California and all that? I don't know if you've heard of that, but that was just
I've heard. So I put myself out in the public a fair amount too, and I get a lot of comments from people about this and that and the other. And I don't know whether they're serious or whether they're trying to troll me. For the most part, I just try to ignore it because, I mean, everyone is entitled to their opinion, right?
Yeah.
But I also, for me personally, I don't believe any of that stuff. It's all a con. It's just a way to suck people's money out of their pocket by getting them to donate to hucksters that are running websites that are selling nonsense. But
Buy my
everyone's
vitamins.
entitled to believe what they can, and they can do what they want with their money, and it's okay.
Okay.
It's a free country.
Okay. All right, back to the surf stuff. So let's talk about those big outlier swells, the ones that are so special. There's a lot of big storms I think that pass through the North Pacific. Some of them are very familiar in size and power, but where that fetch or that power band gets aimed is in the distance. It's those variables, and what makes one of those ones so special. Sometimes they're almost undercalling the energy, but it just falls into you called it earlier, the Goldilocks window, and it's a direct hit towards the islands. Sometimes you'll just see it and it's just moving. You can see the period just moving north of the islands. You're like, no,
Right, it's heading towards the mainland, and it just bypasses you guys completely.
Yeah.
And there's others that they just start falling. They like go over a ridge on the date line. They start falling southeast just a little bit. It all takes direct aim at the islands.
Yeah.
And then
So
the magic happens.
Okay. What really makes those 30-foot Eddie Aikau Jaws swell, like when we get the conditioned black ones where it's just swell of 98 when it was the biggest it was, or what's going to take it to, is it, what do you want to see? What's the perfect recipe for one of those ones?
Yeah. So for me, I'm looking for looking for the MJO, the Madden Julian oscillation, to go into its warm phase. Okay. Or the supportive of low pressure phase. That in turn starts feeding the jet stream. The jet stream will get super energetic. And then you want to see a pattern where it just lifts over the date line and falls a little bit southeast, not coming too close to the islands, but enough so that the storm track falls southeast towards the islands. And then all the winds and the fetch from the storm are aimed right at the islands, but not impacting the islands. So that stirs up the ocean and then makes the swell. You want winds at least 50 knots, but preferably 60 knots in the center of storm. That's how you get a 22 plus second period swell. And then it has to be aimed at you for at least 24 hours. And you want seas 50 feet, something like that. 45 feet's okay. 50 feet is better. But then you start getting higher than 50-foot seas. That results in a swell with a period that's 22 seconds plus. And that's just too much period, really, to be decently surfable, even at the big wave spots.
Get the tow board.
Well, right. Then you're in the tow world. Exactly.
Yeah. But that was with like the Eddie swell last year, I think was the most, it wasn't the biggest I've ever seen Jaws, but it was the most powerful I think I've ever seen Jaws. It was very west, massive period, and they were just stretching and moving so quick on the reef. Like there's certain angles like that 325, 330, 325 that it just makes it really tall out in the North Peak and really huge. These ones were just, you couldn't even take it off and you couldn't even see what the end bowl was going to do. It was so much energy.
Oh, wow.
Crazy.
So literally, I know for out here, I literally have a chart with a square in it. And if the storm is going west to east through that square, and I know exactly where the spot is out in the middle of the ocean, then we're in good shape. And there is literally a box that you can draw for Hawaii and for every good break on the planet, if you know the magic formula and all that's required. And it only takes, maybe 20 years of studying charts to be able to figure that out.
Awesome. We talked a little bit offline, and we were on our first call the other day, and we mentioned a little bit about quantum physics and energy, and you've scratch your head at some of those things. Is anything of curiosity you want to share, like something that's really interesting to you on that side of things, as it pertains to forecasting or your world?
Well, so I'm going to go really off the deep end here, and we go a little bit into quantum mechanics. And I'm not a quantum mechanics guy. I just know what I read, but I've been reading for years about it. And it's really the small world. It's not, storms or your desk or your chair or your house, or even the pepperoni on your pizza. It's not even the atoms inside the pepperoni, or the atoms that make up the pepperoni, but it's the pieces of energy that make up an electron or a photon. And in the end, in the quantum mechanics world, there is nothing solid. It's all interacting waves of energy, right? And so I read an article just the other day from a renowned physicist. I don't remember what his name is off the top of my head, but what they were talking about the essence of consciousness. And what he was saying is he believes that, like athletes, like surfers, they're making these split-second decisions as you're riding a wave, or if you're playing basketball and there's all this chaos going around and you're instantly making decisions. He's going, you're not making those decisions consciously, and it's not biochemical processes in your brain that are helping you to decide whether to turn right or left or jump up or shoot the ball or whatever. He says there's something coming from the energy, even down at the quantum level in your brain, because everything you're made of is molecules and electrons, and they're all built by quantum particles. And he says the consciousness in your brain is actually a product, he thinks, no proof, but of the energy from the quantum world coming into your brain and helping you, sort of guiding you, your physical form, to move through basically an energy field. Your whole, like surfing is your body, but your body isn't a real body. It's an accumulation of a whole bunch of energy riding yet another wave that is comprised of energy on a planet that is rotating around a sun, which is just more energy in space-time. And it's all connected, and there's a reality beyond the physical world that we live in, and we're all connected to it in one way. Now, you can hear that and go, that sounds religious, and it maybe is, or it's maybe just purely, quantum mechanics. I don't know. I'm not going to go down that rabbit hole. But
it might take some psychedelics laying in a forest and thinking about that to see it. Oh man, that's a really good one. That's interesting.
You asked, so I gave you my 2 cents worth. Okay.
We've been talking about conversions of energy on a lot of different levels, and this is the essence of what this podcast is. That's a great example of one right there that you just gave. But obviously, waves of energy, surfing waves, ocean waves are way down the line of a bunch of different conversions of energy. Yep. So, in your life, as you live your life, what's an interesting or important or fascinating conversion of energy that you like to look at, or just that's important to you? And it's a kind of a multi-dimensional question. Is it positive, negative, and how can we live more harmoniously with it? And you just gave a really great answer to it. But
so my wife likes to backpack. So she drags me on backpacking trips, and we go up into the high Sierra and places that I would never thought I'd ever be able to walk in. But you're out there walking, you're out there for a couple of days, you got all your food and your tent and everything on your pack. You're days away from any civilization or really any other person. And you just feel this very deep connection with nature, with, oh, this is where I should be. This is who I am. This is really my place in the grand scheme of things. And it doesn't even, it's not like, oh, I want to go hug the trees or something like that. It feels even deeper than that. Like there's something going on here that I know I don't understand what's going on, but I know I'm part of it. And it's really cool to be part of it. And I'm very appreciative of the opportunity to have this experience and to recognize that I'm having it and to be able to share it with other people. And we can talk about it and go, how cool is this? The words can't express the deep feeling of connection with something bigger than yourself.
Amazing. That was very beautiful. That's
Oh, thank you.
That's where you go when you don't get the Sunday videos, right? When you're
that or skiing but I mean, so to me, surfing is that same thing, especially when you're out with just a buddy or two, and it's not the mad crowd scene, and it's not a billion pros jockeying for the shot on the, on the magazine or whatever, where you're just sitting there and a dolphin swims by or a seal goes by, and you're there with nature, and you just go, this is that feeling of it's magical, and can't even put it into words, but I know it is, and I'm glad to be here.
That's awesome. It's something bigger than us. I know what you're saying, and I've felt that feeling when nature is so powerful, and it'll make you feel so insignificant sometimes, and just
right.
The connection and seeing almost like getting that outer body and seeing that the systems in place and everything's just moving, and now you've just stepped into the system or the matrix, I guess.
The Matrix is a great way. I mean, the Matrix movie, that's really what they're trying to say is there's, of course they turn it into an evil sort of, there's this evil Matrix out there and they're all using you kind of thing. But the reality is the net thought of what the movie was about. There is a Matrix and we live in the Matrix. But the Matrix is way, way, way beyond anything that our little human brains can comprehend. That's sort of this nagging feeling I have all the time. Yeah, I'm here. I'm going surfing. I'm hanging with my buddies. We're having a beer. I go do stuff with people, but you always get this nagging sensation that there's a lot more going on here than I even can possibly comprehend.
Yeah. Those infinite variables, like infinitely time variables, infinitely large and infinitely small, like the scales, there's just things that are so difficult to comprehend our brains or wrap our heads around. Like
we're limited by our experience and what we know, right? And what we've learned. But that doesn't mean we know everything. We don't. Anybody that thinks they know everything is delusional. But we each know our little bit, and we share our information, and we're all working to try to make a better life for our time here on this planet and to make things better for the children and the generations yet to come.
Yeah. And thank you for that. You have an amazing positive influence on a really large community, and coming from me that's been a user of it, your product, thank you very much.
Well, thank you.
Been an honor to chat with you.
I do it so that people can enjoy, that's what it's all about.
Okay. So now I got a little deeper connection to the bat line. You might be hearing from me on some of the big swells, and
oh, that's fine. You know how to get a hold of me.
Yeah, and the other part is always extended. If you want to come out to Jaws and come hang out with us and check the show out, we'd love to have you guys out there.
I would love to come sometime. We'll see. Maybe I'll take you up on it.
Well, thank you, sir. That was really awesome. I'm going to end this on this and hang out. We'll go offline.